And we are ready to go.
Good afternoon, everyone, and welcome to day 2 of the 4th Annual Digital Transformation in Government Conference. My name is Steve Donahoe, and I will be your moderator for this session. This session will be recorded, and it will be available on the conference website in the next day or so. We'd ask you to please use the Q&A button at the bottom of the screen to ask your questions, and I will direct them to our speaker at the end of the presentation. Today's speaker is Dr. Stenio Fernandes, who is an Assistant Director for Data Science Innovations at the Bank of Canada. His talk will be entitled Digital Transformation and Innovation Value Stream in Data Science. Dr. Stenio Fernandes is the Assistant Director for Data Science Innovations at the Bank of Canada, where his primary focus is to shape the data science innovation value stream and guide research and development of cutting-edge technologies, such as quantum computing and artificial intelligence. He is also an adjunct research professor at Carleton University and has previously worked in the industry, Element AI ServiceNow, leading teams of AI researchers and developers. Please join me in welcoming Dr. Fernandes.
Thank you, Steve, for the introduction. Welcome, everyone. We have lots of things to cover, so I hope you got some valuable knowledge and insight from this presentation. So let's get started. First, so first a disclaimer, that's the usual when we make presentations from the Bank of Canada point of view. So the views expressed by the speaker do not necessarily reflect those of the Bank of Canada. Right? The agenda for today, we covered two major parts, two major aspects of the innovation value stream. So I want to clarify some concepts and definitions and shed some light on rationale behind a framework that we have in place, right? So we'll discuss a little bit about innovation, the TRL framework specifically adopted to data science, and value stream in data science innovation in general. And then we go towards practical considerations. How do we actually implement the innovation value stream in data science at the Bank of Canada? So that's my main role and responsibilities at the bank. So we'll talk about innovation missions, and we'll talk about parts of the applied research framework that we have to that we follow. So let's start with the core definitions and rationale. So the main reason I bring this topic is because when we talk about innovation, if you Google innovation, what is innovation? So we'll see like 40, 50 different definitions, right? So it's really hard to understand sometimes like what exactly we mean by innovation, right? So I bring some different perspective, right? So let's start with what is not innovation, right? So I have a few statements, several statements from different people. First, some of them from my own view, like it's not about generating ideas, right? So ideas themselves, there is no value. So you can generate lots of ideas, but intrinsically there is no value in the ideas. We need to keep moving on the application of those ideas and the adoption of those ideas. I will talk about adoptions all the time. So, and related to that is not creativity, right? So creativity is a thinking process. It's not an invention or massive breakthrough in technology. This is the consequence of innovation. It's not also research per se, like pushing the edge of research, like doing some fundamental research on discovering new things. It could lead to innovation, but it's not innovation by itself. And after I did some training with MIT on the leadership and innovation, and there is one quote from MIT which is like, innovation is not a singular moment, right? So it's a process in general, right? So and then we can start talk about what is innovation. So different views, but some of them you see that most definitions I bring, it comes from MIT, which is one of the most innovative universities in the world. And so the first thing is like, it's a process, right? So it's a process of taking ideas from inception to impact, right? So you see common grounds around those definitions, right? So David Neo, which I had some, I took some courses with him, like said that innovation is adopted creativity, right? Uh, a third definition is like, innovation equals to invention times adoption. So if you don't have adoption, if your adoption is zero, so you're not innovating, right? So if you're not creating new things, but it's adopting, if you're not creating, so that means that you have not innovation, you're just replicating what's out there. So I like also the definition from OECD, which is a production or adoption, assimilation, exploitation of value-added novelty in economic and social sphere, right? So, and it's very clear about what is innovation, which is a combination of the definitions, or not the definition that I presented. It's like, it is both a process and an outcome, right? So I'd like this to be clear, because everything that I'll be talking later is related to this, is related to process and related to the outcome. And there are some particularities in AI and data science that deserve attention to that. All right, so let's move on to the next slide. Yeah, so there are some, I'm going to skip some slides because there are too much content to cover. But essentially, there are some deep dive on the definitions of innovations, because as I said, like, is a process, is an outcome, but there are lots of things that we can do, right? So it could be related to process, could be related to cooperation, or could be related to the whole organization. So and I highlight to the last 3 bullet points is very important for people to understand, is the process innovation. It's key and it's crucial for the organization to be successful in bringing new, adopting new technologies and new ideas, right? So process innovation, like the implementation of a new or significantly improved production or delivery method, this is highly important, very important in AI and data science in general. And also it brings the discussion at the organizational level, right? So the implementation of new business practice and a collaboration with different or similar organization is very important to foster, to encourage that innovation. But specifically in the realm of AI and data science and machine learning, so the research and development and scientific science and technology innovation is very crucial, right? We've seen some interesting progress and at high speed at recently. If you are following the development of generative AI like ChatGPT, so it was massive adoptions from November, December last year to today, with like 120 million users in a short time frame, right? So but behind that, there is a huge effort on research and development and in science and technology, right? So we will talk about this, and for us at Bank of Canada, we adopt some strategies and some tactics to make sure that we go in the right direction and we go with the right pace, right? So first, I'm going to give you an overview of the TRL framework and related to data science specifically. So TRL, it's a generic framework. So there's the technology readiness framework adopted and advocated by several institutions like NASA, Government of Canada, US Department of Defense, and many others. And it's essentially, it's a system to assess maturity of a particular technology, right? So we have to start at some point, and then we need to move towards a higher level of maturity of the technology, right? And so there is this scale between 1 and 9. I'm pretty sure most of you are familiar with that. 1 being an exploratory level, and 9 being the most mature technology you can have, right? So, but TRL enables one important thing, which is a consistent and uniform discussion about the technical maturity and how can we make sure that if such technology bring values, how can be widely adopted into the organization in general, right? So I'm gonna quickly move through all those levels, but I'm classifying in groups. You see that, so I'm calling like group A, which is explore. So TRL level 1 to level 3 is more related to, we have the expertise in-house. We know how to do this fundamental and applied research to discover new things around that particular problem that we have to solve. Data is kind of available. We can generate synthetic data. So now I'm talking about TRL in the context of data science. So we can generate synthetic data. We can have a small data set to test our ideas. Like, can we move, is this technology, this particular model, a set of models, and I'm talking about ML models, AI models, can solve that particular problem, right? So, but it's still, we're still not sure, right? So we're exploring the possibilities here. So, but we need to move the needle from level 1, level 2 to level 3 at least, to make sure that we have the proof, a successful proof of concept project, and the outcome of this can trigger or can open the avenue for different R&D, research and development tracks, right? Or we can move to the next level, which is the proof of applicability, right? So it's okay, now we tested the idea, but now we want to see more from that. Like, what is the value we're bringing? So can we do more experiments in a more controlled environment, not just with a small data set, but like having testing different hypotheses, answering different research questions, right? So we're trying at this level of applied, of proof of applicability, we're moving toward the direction of demonstrating value, right? So, and now it's very important to get our hands on the customer data set, on the use case specifically that will solve that particular problem, right? And what's important, like if this is a feature or a product on itself that will solve that particular problem, so we need to start discussing how the integration look like and how the deployment will look like in the near future, right? So moving from TRL level 1 to level 4 to 5 to 7, so we are more in the testing the robustness of the solution, right? So we started with exploration, then we moved to a tailored solution for the user. In our case, is our internal department. And then we move in direction, okay, that's good, it brings lots of value, but now we need to make sure that this system, the models can run in a real environment and is robust enough that we can trust, right? So that's our main goal. And integration into the existing environment is always a challenge. So, and then when we go to the deployment phase, so in general, the applied research team or the research team work on that initial solutions are more like hands-off, right? So we hand off those results or the outcomes to the appropriate team that will take care of deployment, right? So it's a matter of, if needed, to scale the solution, to replicate into multiple customers, and make sure that the training and inference pipeline, which is the concept of and machine learning and AI, like it's fully operational, right? So, and then when we reach that level of TRL 7 to 9, we can say that innovation was successful. We moved the needle from level 1 to level 8 and 9. Not all projects start with level 1 or 2 or 3. Some of the projects are more mature because of the research, previous research in the topic. So we can start from level 4 or 5 and move to level 8 or 9, right? So I like to bring that discussion. And one thing that we discuss internally is that talking about TRL, 9 levels of TRL, sometimes it's confusing. People say, okay, but what is exactly 3 or 6 or 5, right? So I prefer to be somewhere in the middle, like aggregating those levels as I show you, as I presented, like 4 levels. I prefer to be at that level, like discussing about exploration, applicability, development, and deployment, or even 3 levels, like basic and applied research, and demonstration and optimization of the solution, and then a well-established model or system that is running and is used by several departments, several people in the organization. So this is the simplification, right? So, and of course, if we talk about the AI maturity level, so that's where I said, like, when we are reaching those levels or above those levels, we'll talk about innovation, right? So this is, I forgot to put the reference, but if I'm not mistaken, this is Gartner. So it talks about level 1 of the AI maturity model is like, okay, we have some interest, there are some risks, but we have some interest on that. Level 2 is like, let's do some experimentation in data, with some small data. AI is in production at level 3, it's operational. Is it systemic when it's pervasively used across the board? And it's transformational when it's part of the business, right? So part of the DNA of the organization. So that's the level we want to move, right? So when we explore a lot the first levels, but we want to move everything towards level 5 in this framework, but also level 9 in TRL framework. So I'm going to skip some of them, but it's essentially talk about the same. You can check those slides later at the website, right? So, but what is value stream, right? So I'm talking about different similar concepts, but kind of related. So, what is a value stream? So there are 2 main definitions, one from PMI, so the Project Management Institute, and the other from Lean Six Sigma. So all the actions required to create something, right? So it could be a product, could be a feature within the product, or a service from concept to production. So it's the same thing as we are talking about before, about TRL, maturity levels, all this kind of stuff. But PMI is more precise in terms of it's a set of actions that take place to add value, right? So it's very specific and linked to the connection of from the initial request from the business until realization of the value. So this is the value stream. And in data science and in AI ML, like it's very tricky because there are lots of layers of complexities that we need to address. I'm going to show you one slide. But the main message here is if the organization only have like, oh, this is the department or the team that is doing innovation, without the right connections, what I call loosely connected innovation, there are lots of challenges, right? So what we will see is lots of silos, right? So it can prevent the cooperation between teams, and delivering value might be very difficult. So a team can create a very advanced solution, like in terms of research, at the edge of the research, bringing to the organization, having the right data set, proving some concepts and value, but still not be adopted because of the lack of this integrated solution as a value stream, right? So if we have loosely connected innovation teams, we might face several challenges, like what is the prioritization, how to coordinate those efforts, what I call blurry R&D, which is like it's really hard to identify the potential and of the offerings of that particular team. So I always advocate for a broad view and always connected between the business goals within the organization and all the teams that can bring in interesting solutions to the business problem, right? So in that sense, the data science innovation value stream, it enables lots of things. One of them is articulating this discussions and and the issues from our customers and partners internally and sometimes externally, allocating efforts, right? So it's very important because solution needs to be funded in terms of resources, in terms of platforms, in terms of teams, tools, whatever the team needs to make sure they bring the right connections within the organization. So it's a coordinated effort, right? So should not be and must not be siloed groups doing innovation. And it enables like from going from a proof of concepts to prototype and to full deployment. So yeah, so the pillars I see and that we are applying is that first start with the clear, well-defined and relevant strategy, and that everyone at the organization understands, right? So it's very important because the complexity of the concepts, especially in data science, is so hard. So you need to make sure that you communicate well within your team and outside the boundaries of the group, right? Of the data science group. Always, as any attempt to innovation, like accept that failure is a possibility and be okay with that. The main message is learn from those failures and move on and try to not repeat the same failure. And have a well-structured teams and groups, let's say small teams or cross-functional teams that we call squads, to make sure that they bring the best of both worlds, like the user and the ML AI side, to solve that solutions. So that is will enable a successful outcome of those projects, right? So, and in terms of innovation value stream of process improvements in AI, and it is everywhere, right? So we start here from the push and pull type of approach for technology adoption or innovation, but also we have like all this exercise on prioritization and planning, to the ML operations, to the machine learning development lifecycle, to the research and applied research best practice. So everything is connected, right? So there are the needs, the strategy, the funding, the solutions, and we have the enterprise architecture, the governance, the security, the data management. It is a very complex environment that everybody should be involved in those discussions. And when we talk about specifically for the applied research framework, we are here in this quadrant, which involve lots of things, especially on the machine learning development lifecycle and then ML ops and applied research. So one thing is that we adopt and we are pushing in that direction is to have this push and pull dynamic for technology innovation. Like we have the innovation missions. I'm going to present some details about this. And we have a research and applied research framework and playbooks to make sure that we always move from one particular TRL level to another one, right? So we always aim at the highest level we can be. Yeah, okay, so let me check time. Okay, 25 minutes. Yeah, so practical considerations. So we have the innovation mission, right? So the implementation of this data science innovation value stream or innovation approach, I have the three different what I call main buckets for allowing creativity and having room for exploration, right? So the projects we develop are always categorized in some of the buckets. Some of them are continuation of previous one, meaning that we need to solidify our knowledge. We need to solidify to gain understanding, better understanding, or deep understanding of the solutions, and the solution landscape, the problem landscape at this stage is kind of understood. We have also long-term strategic projects aiming at producing high-impact deliverables and strengthening existing collaboration within the departments of the bank, right, and our group. And I also give and encourage room for creativity, right? So what I call the innovation missions, which is, I'm going to show some details, like it's 20% of the people's time is related to room for creativity. There are some benefits that is clear from using the approach. First, quick wins, right? So some of them we can quickly show value and show results. Some of them is more long-term strategies. So we keep improving our innovation life cycle process and bridging some uncertainty gaps. The innovation missions, in particular, they are very important because we define the success criteria of something that we need to explore, but also the kill criteria. So we are at the TRL 1, 2, 3 at this point. So we don't know if a given approach that we can search from research papers and find some solutions in the research papers can solve the problem. And if it solves the problem, this can be scaled, or can this be robust enough for our operation? So we define not only the success criteria, but the kill criteria. So we will not push or try to push in the direction of the applied research going deep if the initial results are not good enough, let's say, right? So we define those things, and it's more like de-risking the technology and more research oriented in that sense. That's why we only lose like 20% of our time to devote to that at most. So some examples of work stream that we do at the bank, we are solving very hard problems, operational problems, macroeconomic problems. We have the economists, the senior economists work on different types of problems. We have the partnership with them, the data science, the quantum computing team, solving different types of problems. So here are some examples. So we work with quantum ML, solving quadratic and constrained binary optimization problems, which is very hard, but quantum can have like really nice solutions on that. We're exploring QBM, so it's called quantum Boltzmann machines. We do lots of deep learning technologies, especially in the field of forecasting, time series forecasting, which is my field of expertise before joining the bank. We explore different avenues on explainable AI, causality, transparency, explainability, debatability, privacy, all this kind of new technology. We explore a little bit on that. And yeah, so, and we have on top of that what we call the data science innovation management, which is cross-functional and horizontal to my group specifically. Yeah, okay. So last 10 minutes. So we have a framework. I'm going to skip some of this slide, as I said. Like we have a framework, but one of the important part of the framework is the applied research framework, right? So we're not trying to, at least in the data science, not in the economist has a different view. They have a research agenda specifically. We are in the data science team, and our goal is not to push the edge of research, is to apply research, right? So it can be the latest results of the latest models that we've seen in the literature, and then trying to bring some proof of concept, proof of values, but also yeah. So that's not our goal. It can be, but it's not our main goal. So the applied research, the definition we use again is from OECD, is the original investigation undertaken in order to acquire new knowledge, right? So we want to see if that particular approach, methodology, technique can solve our problem that we have at hand. It's more like practical, and we have some clear objectives, not to improve performance of the particular domain, right? So, and we have the role of the applied researchers in the team, which is refining the technical problem, de-risking the technology, addressing robustness and the scalability of the problem, having an in-depth view of the knowledge of the state of the art in the literature, and of course, validate or invalidate the hypothesis and answering research questions by precise design of experiments and conducting those experiments. Yeah, so applied research is everywhere. It means like we can use applied research, our applied research framework, to privatize or to help on the fundamental research or to find client-specific solutions. But most of the time is to de-risk the technology that we need to have a better understanding to solve that particular problem. One key aspect, which is this, this slide is very loaded, but what I want to show is that is the difference between the traditional software development lifecycle and the ML and AI development lifecycle, right? So here we see like a kind of a straight line. We have the steps going from planning to analysis, design, build, test, deploy, and maintain. That's it. In AI ML, it's more tricky. You see lots of inner loops because you go to the goals, check the data, collect the data, and check the data. Yeah, we can achieve that goal with the data. So we go back to the goals, refine, go back to the data, and then we can move to build the model. And sometimes like, yeah, okay, we cannot extract much from there are no models, for example, ready to use those data. So let's go back to the data, do some feature engineering, create new data, manipulate the data, and then go back to the modeling. Maybe we can even go back to the redefining the goal. So there are lots of loops here, right? So it adds lots of complexity, and it's not easy. And even when we deploy the model, there are some things that the data that we train the model and we collect the model might have changed, and then we need to do it all over again, like rebuild the model. That's a concept, a term called concept drifting. So when concept drifting happens here, we need to go back to data, build the model, reassess, reevaluate, and again, right? So this is very complex. That's why we need to put all the framework and the playbooks in place. There are two pillars. We are short on time, so I would like to show one of them. But the two pillars for successful innovation technology and adoption of that technology in data science are a very clear systematic literature review, and I'm going to show some data why we need that, right? And a very precise design of experiments to answer all the questions we have and to make sure that we are validating the hypothesis we have correctly. Yeah, so I'm going to skip some of them. But the point is, why do we need a systematic literature review when we are in an organization that we are not academics, we're not publishing papers? So if some of you, I believe most of you have gone through this thing, like we need to do a literature review to write a report or something, or a thesis or a master thesis or a PhD thesis. So we have to do that, right? So like, why are you doing this in academia? Like, this is a particularity of AI ML, right? So there is the number of papers published and solutions to some problems are huge. And the numbers I will show you, it might surprise you. So this is the report this is the 2023 AI Index report published by Stanford 1 month ago, right? So this is the number of papers published between 2010 and 2021. So in 2021, we reached 496,000 papers in AI ML published 2 years ago. And this is an exponential curve. So this is insane. So this is Cornell repository on machine learning. So in 1 week in April, we have like 530 papers submitted to that repository, right? So it's humanly impossible to keep track of this. So we need a system that could track and could be very precise in finding potential methods and techniques to solve a particular problem. So that's why we use and we advocate for a systematic approach to go to the literature and find the needle in the haystack, because this is a huge haystack right now. Okay, so I'm going to skip some of them. One important, okay, okay. So this is my last slide. One important aspect is specifically in engineering, but recently in AI, there are some AI ML, there are some recent papers showing that reproducibility in that field is very hard, meaning that you read a paper, you understand the method, when you're trying to implement, get the same data set, and when you're trying to implement, you don't get the same results. So reproducibility in AI is a challenge. Even when the authors publish the code, the data set, you're just trying to run the code, it doesn't run. So it is a challenge right now, right? So, and those numbers are from 2020 from Carnegie Mellon University, showing that scientists have trouble to reproduce an experiment, right? So in physics engineering, it's close to 70% of the papers cannot be reproduced. So what's the implication here? Like, we have a solution, we kind of know, let's say this is a multivariate time series anomaly detection problem. So okay, that's cool. Let's go to the literature. And then we find like 500 papers. And I'm not kidding, this is an actual number that I did like 2 years ago. Like, okay, there are 500 papers, 500 techniques that I can test, but it is impossible, right? So we did the literature, the systematic literature review, pre-selected 5 from this 500, start to run some experiments, and 60% we could not reproduce the results. And then say, okay, what can we do? We can keep trying or just discard and move on with the ones that we see some results, right? So that's why this is a challenge, and we need all the guardrails and in place, and a proper framework that we can move from TRL 1 to 3 until we have deployments. It's a long journey, and we need to put some pillars and some framework in place. And yeah, I guess this is it. Yep.
Thank you very much, Dr. Fernandes, for this very, very interesting presentation. I would encourage everyone, if they have questions, please to enter them into the Q&A box, and then I can ask them of Dr. Fernandes. As we're waiting for questions to come in, how important is managing scope? In other words, putting borders around what it is you're attempting to accomplish and not letting that get out of control.
This is a very interesting question, because this is super crucial. So we try to have ideation sessions with the customers, with internal departments that have some problems that AI and ML can help, data science can help. But we come across with this kind of thing, like the scope is too broad. And then we're trying to have a good communication channel with the client, with the user, to see first if what they want is supported by the data. Sometimes they have like, they want like a very interesting thing, but when we look at the initial data, yeah, we can't solve this thing, or the scope of this problem is so broad that the data cannot help. So we need to align with the availability and quality of the data with the scope of the project before we move to the next phase.
Yeah, thank you. Another question is related to the maturity model that you discussed earlier in the presentation. Any suggestions, any tips as how you move from one maturity level to another?
Yes. So first, set the level, the right expectations to people. Like especially when you're at the initial levels of maturity. Like let's make clear that we understand what is a proof of concept, right? So this is a very de-risking the technology at the very beginning. So this is proof of concept. And make sure they understand, because sometimes the expectations are too high, like, oh, you solved that problem, I want to use right now in production, and say, hey, that's not what we intended to do. They intended like proof of concept and then proof of value and then go to robustness. So my suggestion, like, make sure that the roadmap is clear, right? So that you can move from, it could be 2 stages or 3 stages, whatever, but make sure that the expectations are right in the right place.
I have another question. What is the value proposition for government agencies and departments to engage with advanced research organizations when they focused on delivering practical and tangible outcomes?
That's a very interesting question. I believe we had, I'm not sure if any of you saw the presentation this morning or at the beginning of the afternoon from our CDO. So sometimes the problem is there, and it has been there like for a long time. And it is a practical problem. We just need to move the needle from in terms of performance, right? So you might have a problem and a solution in place, like that is solving your problem, but you want to increase performance, and it can be yeah. So like this type of project can be put in this value stream, right? So I can give an example. Like you have a model that is like 90% accurate, or have like a level of performance, whatever performance metric you have, with 90% precision or accuracy. But the business will benefit, the government will benefit from moving from 90% to 95. So this can be this can be done with the value stream, like exploring the new methods and new techniques to move the needle from 90% accuracy to 95, right? So it is solving an actual problem, an operational problem that is in place, but it's increasing performance, right? So, or doing faster, whatever, like one of those, right? So it might require some attention on the research side.
Are there any other questions? One more. Critical success factors at a high level. What are some of the key takeaways that we should think of?
Okay, so in terms of having a very clear roadmap in terms of the figures of merit, right? In terms of adoption of the technology is important for the group. So we don't want to keep exploring the edge of research and say, oh, this is a successful POC, and then having 10 successful POCs a year, and then next year 15. And like, yeah, this is not the best way to do it. Like the key performance indicators, the KPI, should be adoption by the user and number of users using, or departments, or the value we're bringing to them. So this is my my view of how we're going to implement those things.
All right. Well, thank you once again, Dr. Fernandes. If there are no further questions, really appreciate your time, the insight that you provided us with, and once again, our deepest appreciation. And for everyone else, the next session will be starting, I believe, at 20 to 4. So you get a little bit extra long for a coffee break. So see you at the next session, and thanks again.
Thank you. Bye-bye.